So welcome everyone. So glad you are here for CS Ed Week 2023. And if you would like to, we would love to hear who you are. And oh, I actually left that question in from last time. I didn't change it, but let's talk about. You can talk about how you keep your data safe. Can answer that question, or let us know what are you doing for CS Ed Week. Are you doing anything for CS Ed Week? You're all here, so that's good. All right, thank you to those of you that are introducing yourself in the chat. We have people from all over the state of California. Excellent. Thank you for promoting CS Ed Week on social media, Scott. Excellent, excellent. Awesome. Exploring AI. Very good. Yay, a CS algorithm dance party. That sounds like a lot of fun, Rebecca. Love it. All right. Well, excellent. We're going to go ahead and get started here. I do want to let you know I get this question a lot. So while you are typing in your name and reading everybody else's name, I'll let you all know that the slides will be shared with you via email within the next couple of days or so. So you will get a copy of these slides, as well as any resources that are shared. And we will have more AI webinars announced soon. Those will be beginning in January. So you'll want to make sure that you're a part of our CS Ed listserv, which there will be a link in the follow-up email with how to join that list if you are not already there. All right, we have some people talking about QLA. Yes, some of us are presenting there. There's also a KCI CS Ed Week event on Saturday that I've heard some good stuff about. So I think there's a lot of exciting things happening in California. All right, so if you have not done so already, make sure and visit our website. There's the bit.ly there, and this will again be in the follow-up email as well, where we do have our CDE AI guidance. And our essential question, so to speak, today is, what does learning about AI mean for educators and students? So we're not talking about learning with AI. We are going deeper, looking under the hood in regards to learning about AI. And that's why it's such a great time during CS Ed Week, Computer Science Education Week, to speak about this, why it's important, and what our students and our educators need to know in regards to how AI works. So we do want to point out that this the CDE guidance does talk about learning with AI. So making sure that we do that safely, that we do prepare our students, but also learning about AI, looking under the hood, and that is what we are doing today. So I wanted to start with a quick quote from the guidance that talks a little bit about these fundamental skills for educators and students that we talk about here in regards to artificial intelligence. And so the quote here says, "A growing knowledge about AI improves safety and efficiency when utilizing AI systems and supports, and it supports understanding of potential inaccuracies and biases that may exist in their outputs." So essentially, when we learn about AI, so we do this bottom right skill, we start to demystify AI, all of the other skills we can do even better. Once we start to learn how it works, then we better understand the presence of bias and the societal impacts of AI. As we start to demystify it, we can better leverage its capabilities and critique its inaccuracies. And as we demystify and look under the hood, we understand how to keep ourselves and others in our care safe also. So this truly, even though it's like the fourth one on here, it really is the foundation and drives all of the other skills for utilizing AI. So learning about AI really helps us to better learn with AI. So again, this is our focus for today. And We're going to begin with our first speaker, Rudy Escobar, who is actually all of our speakers today are involved in the CS for CA AI work group. And so they come together and talk about AI once a month. And probably think about it a lot more than that as well. And so our first speaker here is Rudy Escobar. He is a STEM and computer science coordinator for Stanislaus County Office of Education.
Thank you, Kat. Can you hear me well?
Yes.
Yeah, Mike is having a little bit of problems. So, hello everybody. Thank you for being here today. So, I'm just going to introduce the topic for you, just for us to ground ourselves to think about what is AI and how AI is really being involved. And Matt will actually continue with this, giving us a little bit more in depth about what we're talking about. But I wanted to start showing you by what's the progress that is happening. There's progress already happening right now in sustainable future. With AI, for example, Google has right now a project Light, and this one uses AI to help city traffic engineers to optimize traffic lights at any intersection when the traffic flow and cut emissions. So I want you to start thinking about how this is a brand new technology that's coming out. There's machine learning involved, there's AI involved into this, and there's somebody behind the wheel trying to figure this out. Not just one person, there's a lot of people trying to figure this out to how to make it work better. We can go to the next one. Another feature that we have here is, and just to keep it to ground ourselves, everything I'm talking about today is really about sustainable future. Is really where we're going with everything. Thinking about how can we make things sustainable. So AI is really being involved in making sustainable future. And here's another one, a new feature in Google Earth, which it helps cities to better incorporate solar into their development plans. So using the API from Google, they could actually get it, be able to get these maps, and engineers can actually look at these and incorporate where is the best place to put these solar development plans into action. So this is another cool feature that is coming out with Google Earth. Next, please. So I want to ground you and think you about why is this important to us. So why am I showing you all these cool things about sustainable future? It's not just computer scientists. It's not just AI, engineers. There's a lot of people that are involved now in these things, and it's so important for our students to really have, to be able to understand AI, not only from using the AI, but really understanding how are those models being fed, who is developing those models, and how are those models beginning to feed the data. So here's some questions that I want to start you up with for today to think about as we move through our presenters. Are we preparing our students for the present and for the future? How are we preparing them? And are we making our students only users of AI, or are we preparing them to stay ahead of the computation and to be computational thinkers to understand how AI works? Now I want you to think deeply in those questions because we are getting there's a lot of excitement about using AI, but really, are we actually having understanding AI, and are we really making our students computational thinkers to think about how AI works and not just use AI? So with that, I'm going to pass it on to Matt.
Awesome. Before we do, thank you so much, Rudy. I have a question. So do you think that is it just computer science, those that want to get a computer science degree that should understand a little bit about how AI works? Or like who should we be teaching about AI to?
I think it should be everybody. It should be every student that goes through our school system needs to understand how AI works. That's the reason why I placed those two examples of Google Earth and all the sustainable future, because our kids will live in that future, and understanding how voting happens, how things are happening in decisions that are being made, how engineers are actually choosing these things is very important for students to know how that happens before they just start using it.
That's a good point. I definitely want our legislators of the future to to understand how all of this works. So yeah, certainly not just those that are going to create the products, but those are going to use them as well. Thank you so much for that, Rudy. Appreciate that. I do want to say to everyone that we are watching the chat if anybody has any specific questions. And if there's time, we can answer questions at the end as well. So let's go ahead and move forward. And we are going to hear from Matt Johnson, who is also a member of the CS for CA AI work group and is an AI teacher. So teaches high schoolers about AI. And I asked Matt to talk about what do you think students need to know about AI systems and how they work before graduating. So Matt, welcome. We'd love to hear from you.
All right, thank you much. Good afternoon, California. Thank you for being here on this incredible topic. Before I get into anything else, I wanted to show you guys what I'm hoping you actually take from this talk of mine. All right, so what is that? Well, it is a video that just won an award for showing something really beautiful pertaining to neurons firing and growing and making connections. And this is what our brains are doing all of the time. This is what they're doing when they learn in our class. This is what we're learning when we take something from conversation. So I'm hoping you'll get that from me today. But if you don't, well, you'll get it whenever you do take something from somebody. But I'm not just showing that to you because it's kind of a witty thing. The thing is, neurons and neuroscience are at the basis, at the foundation for the revolution we've seen in artificial intelligence recently. All right, so the algorithm I'm talking about here are artificial neural networks. So what I've presented here is a drawing, which is of course still simplified, of an actual neuron in the brain, as well as your basic artificial neuron. So you get the idea of the computer in the 1930s with Alan Turing. Come the 1940s, you get the first papers written about the idea of making artificial neural networks. Basically, recognizing that if we can look at what's going on with any particular neuron cell, and we can turn that into something we can process with a computer, then we might have the basis for a fundamental unit of computation. So to just go into it a little bit here, the top thing, you're seeing the actual cell body and nucleus of the cell. On the left, you see the dendrites, which is the input part of these cells. And then you have the axon, which is the big output that then goes off to the terminals, which then connects to other cells' dendrites through synapses. All right, so below we have our simplified version. We've got our inputs coming in, we've got our outputs coming out, and then in the middle, emulating the actual cell body, what we have are a series of algorithms. And the first part of it is basically summing things up, adding in all the different quantities that were put in. And then we have a function that we call an activation function that says what should be outputted. And the essence of it is neurons don't fire, don't fire, don't fire, fire, right? They wait until they pass a certain type of threshold. That's when they fire. So we need algorithms for that particular purpose. And we've gotten more sophisticated over time. But fundamentally, this is the fundamental unit of what we are using when we're doing all of this stuff pertaining to deep learning, transformers, all of this stuff. It's all based on specific cells in the brain. But that's not all, right? It's not just that we have an algorithm that's based on the brain. Our modern hardware, well, I wouldn't say was basically designed by the brain. It's working so well because it has something very important in common with the brain. So whereas a traditional CPU is based on the idea of we're going to have a central processing unit that does all of the heavy lifting, a GPU is able to operate in parallel, and that's a graphics processing unit meant for graphics, optimized for video games traditionally. That is looking at, if you imagine a screen where there's many different pixels that are effectively doing the same thing, I don't want to do them all individually, one at a time, serially. Can I just do them all separately at the same time? So, yeah, you can. And that's not going to be the best thing if you've got a bunch of serial complicated tasks. That's what a CPU is perfect for. But for artificial neural networks, neurons are a heavily parallel thing in our brain. So really the algorithm needs that too. And it's worth noting here that while the algorithm comes into play in the 1940s, and it has various times where people are excited about it, if you go back 20 years ago, most people in the field of artificial intelligence are down on neural networks. They feel like they've gone as far as they can go, and there's not going to be much more we can do with them. And then the GPUs happen. And we couldn't have gotten them too much sooner because of the technological requirements. But this is something that didn't have to happen and probably could have happened a bit sooner. It basically comes where you have the makers of graphical processing units sitting down with AI people and realizing, hey, we can do this really well on our chips. And of course, I'm talking about the company NVIDIA that has rode this from just being a small video company to becoming one of the power players in artificial intelligence. So these first two things, effectively software and hardware, understand that first and foremost, these are simplifications of the brain. That's why they're working. And as we're able to get more and more sophisticated along these lines, we're going to be able to have artificial intelligence do more and more what humans can do. But of course, that's only the basic infrastructure. You also need it to learn from something. And that's where our third component comes in. The data. We're living in a digital world, folks. The internet has changed everything. There is a quote from Eric Schmidt, former CEO of Google, that said that every 2 days we're creating as much data as the entire human civilization created from its beginning to 2003. 2 days compared to millennia. And here's the funny thing, folks. He said that in 2011. So look at where 2011 is on that chart. We're doing way more now. All of that data, that's stuff that we can feed our machine learning algorithms. And not all of it is social, but if we look at ChatGPT on the right, we're seeing that is human. The Common Crawl, that's just websites in general. Web Text 2, that's Reddit. Various books, Wikipedia, boom, that's how you're getting ChatGPT. This combined with the other two things, it's feeding off the sea of human thoughts. That's what's going on, and it's going to get better and better. Of course, that's exciting, but it's also very scary. So that brings me to the last point that I really want to hammer in. So while that other stuff gives us what I can give in terms of the under the hood part of artificial intelligence with the algorithm that's dominated the 2010s, it doesn't necessarily tell your average students, well, what should I be going for in my education? So just computer science and then everything's going to be good? Well, the reality is, as technology blooms faster and faster and faster, that means things are changing faster. Requirements of employees are changing faster. So what do you do as somebody who's going to go into the workforce and is going to need to cope with all of these things? Well, the phrase that I keep saying to my students that I'm sure you've all heard before, but I just think it's more and more relevant, is lifelong learning. Basically, you're going to graduate from high school with a great high school education. You're going to graduate from college with a great college education. Hopefully that helps you get a good job. But it's not going to ensure that you are marketable for a good job 20 years from now, 25 years from now, 30 years from now. It's hard, but the reality is, particularly if you're in the STEM space, you need to keep up with the times as best as possible, and you're not going to be able to depend on the job that you work for, the company that you work for, to just say, hey, take a break from what we need you for, go learn some new things. So this is something that you have to bake into your routine in life. And it's hard, but the good news is, for anybody in this situation, you have no idea how good you are at learning right now. If you're in high school and you're in college and you're actively devoted to this, essentially, you've got big learning muscles, and you just need to keep this going. Make it part of a weekly routine. Keep on doing stuff along these lines, and you're going to keep building skills for the future. And to be clear, this is very true of computer science and STEM, but it's anything, right? You want to learn how to throw poetry? Poetry. You want to learn how to throw pottery or write poetry, right? go apply yourself to that. Anything along those lines is going to make it easier for you to continue with those skills going forward. All right, I see that there were some questions in the chat. Should I try to address those, Kat? Yeah, so
absolutely.
common crawl versus web text, my understanding is that the common crawl is something that's just basically seeking out everything possible on the internet. And the web text was something that was specific, focused on Reddit. Now, that's just from what I have looked up and found. So my apologies if there's a mistake, but that's my understanding on it, that you have a general internet query, and then you have one specifically for Reddit, and you have one specifically for Wikipedia, as well as stuff for books.
And Rudy says Common Crawl is open source repository, if that's helpful in the explanation as well.
Okay, and I'm reading Enoch's question, and I don't think I have an answer for this. I don't have the expertise to say. So it's an excellent question, Enoch, but I'm afraid I can't help you with this one.
I think so the question for those that are watching and or listening and can't quite see the chat is about, you know, how do we what do we do when there are these data privacy regulations and so these students can't use these tools, right? So how are they going to learn about how that works? And then the follow-up question was, is there a move afoot to add AI to the California National Student Data Privacy Agreement? So I don't have an answer specifically to that, but I will say a couple of things, and that is that you know, there are, and I'd love to hear more from you, Matt, as well. I know Vicky is going to talk about some ways that students can start to learn about how AI works without actually utilizing any AI tools that are not FERPA and COPA compliant. And so that's one thing we'll speak about. I would also say that, you know, a lot of these tools, they weren't designed for education, but we still need to prepare our students for this. But I will say that already we are seeing generative AI make its way into safe platforms. We see Canva has Magic Studio, and many of the Magic Studio components are there. There's Teachable Machine with Google, which is something that students can explore. There's, you know, Google is working on Duet AI, and we'll see how that rolls out. So I think that the ed tech companies are working on it. But I don't know specifically if they're, you know, in regards to the California National Student Data Privacy Agreement, if there's any move to change that. But I do see that there is a, there are companies and vendors that are really trying to figure out how to make this work for kids in a way that is safe and is legally compliant. Matt, did you have anything to add to that in regards to teaching students in this space with data privacy?
I guess I'll say two things. One is, absolutely, we're seeing people try to create walled gardens right now. Things that will keep kids safe from these things that school districts and parents can feel comfortable with. Now, I think it's always going to be a challenge with generative AI, right? It's not as predictable as other tools, but that's definitely a movement. Beyond that, what I would say is there's a lot of school districts that ban ChatGPT and then unban, right? So my district is one of those, right? I remember being in conversations with the folks at AI for CA saying like, well, my district has a good attitude. They haven't blocked it. And then they blocked it. And so then some of us really pushed hard to get it unblocked because I just don't see an actual argument for why it is best for the students to not have access to it. So I think it's the two fronts. We're trying to make it safer. We're trying to have walled gardens that protect the students. But I think there is also a recognition, school district to school district, that you can't just ban it and forget it, right? You might think you're keeping the kids safe. The reality is they're doing this stuff on their own. So I would rather they learn about it with a teacher than just get thrown to the wolves.
Yeah, thank you for that, Matt. I also liken this a bit to when social media started coming out, right? We knew that there were students that were on social media, and we weren't necessarily going to say, okay, all the students in my class, I want you to all log on to Snapchat so we can learn how to be good digital citizens, right? But at the same time, we had a lot of conversations. We talked about what is an appropriate way to speak digitally and to be a good digital citizen and such as well. So absolutely, thank you for that. Yeah, so, and Rudy's talking too about, Chat GPT and some of these, there's a lot of bias in there. There's a lot of data is being collected. We don't want students may unknowingly, put personally identifiable information into these systems. So there are certainly concerns. But again, yeah, there are certainly vendors working on this. There was an article by Forbes that predicted, I don't remember the dates, but very quickly that these LMS, these learning management systems, will likely have generative AI built into them within the next, couple of years or so. Because that's what people like all of you are asking for, right? We want to educate our students. We want to do it safely. We want to prepare them for today and tomorrow. And so I would say I appreciate all these questions, and I love all of the enthusiasm. And I really do think that safe ways of engaging kids in these digital platforms is coming. I really appreciate all of your insight on that, Matt, for sure. And yeah, Stephen's right. Reading that terms of service and end user agreement is really important as well. And as we're talking about this, I want to shift to the younger grades also. And so we're going to hear next from Vicki Sedgwick, who taught elementary CS for a long time and was also a CS TA K-5 standards writer and a working group lead for AI for K-12. And so Vicki's going to talk a little bit about, gosh, I mean, we certainly, how are we going to get our kindergarten students to understand how AI works, right? This is something that is seemingly quite difficult, but what does this mean, Vicki? Can you talk to us a little bit about how we could teach our youngest students about AI and why that might be important?
Definitely. I'm going to be pretty practical here. I'm going to give you some possible lessons for K to 8, basically, that you could use today, probably, most of them. Again, you're going to have to check on things because some of them may be blocked by your school, but a lot of them are even unplugged activities that you can do, especially in the younger grades, where they're not touching anything. Right. So it's not like you have to worry about anything being blocked, but it's teaching them how things work. But before we talk about how we might do that, we should talk about what they should know, right? What does it mean to teach kids about AI? That's kind of where AI for K-12 comes in. AI for K-12, which was originally sponsored by AAAI and CSTA and a few other groups. They've identified 5 big ideas of AI, and they were used kind of as a framework to put together guidelines on what students might need to know. These are actually being altered a bit even right now because of generative AI. Some of what they originally put as their framework needs to be adjusted because when they were written a couple years ago, it didn't exist. Now it does. So they're going to be adding some additional things for generative AI in the coming months. So AI can do 4 main things, right? It can understand its environment, which is perception. It can learn new knowledge and skills, which is learning. It can plan and make decisions, that's representation and reasoning. And it can interact with humans in the environment. That's natural internet interaction. That's 4 of the 5 big ideas. The 5th idea, and in my opinion, the most important is the impact of AI on people, the societal impact. And that's really where teachers can be extremely helpful with kids, because you can see all the possibilities and the cool stuff you can do, but we need to talk about those biases and address them, even starting with the young kids. So we're going to we're going to look at some ways for each idea of what we can do. So um, I like to start sometimes with vocabulary with K-2, right? We do that with CS, for example. We teach them what an algorithm is, right? It's not a word they're going to use all the time. Perception isn't a word, for example, that they might use or even know what it means. So to start out teaching perception with the youngest kids, I often use this book. It's called Duck Rabbit. And it very much can point out the difference between perception, which is how computers can understand the world using sensors in a way that's similar to how we use our senses to understand the world. But it's not just about seeing something, it's about understanding what it is, right? And so, Duck Rabbit, if you've never read the book, it it asks what this is down at the bottom of the picture there. And some kids will perceive it as a duck and others will perceive it as a rabbit. And so the idea is perception is our understanding, not necessarily what we see. We all see the same thing, but we may perceive it differently. And so that's how I typically will introduce perception initially to K-2. And then we get into senses and things like that, and then compare them to sensors. For a little bit older kids, when they get into start using Scratch, one of the things that we often don't even think about and realize is that Scratch has two built-in things that are AI. They have text to speech and translation, and it's built right into the standard Scratch project. Now, if you're using CS first, it's not in there. But if you're using traditional Scratch, it is. And so if you're doing that and you have kids creating something that uses text to speech, you can talk about how that's perception, right? How perception's involved in that, or how it's involved, things are involved in translation. So you can start talking about those types of activities with things they're already doing, right? And then if you've got kids that you want to take it into Snap, and you've got Finch robots, there are a series of lessons on using AI with Finch robots, and a lot of schools are getting Finches, and Snap is very close to Scratch, so it can be very helpful in higher grades. Next, big idea 2 is about how AI creates representations of the world and uses those representations to reason about the world, to make decisions. So some real world examples: path planning, right? Internet searches, playing games like chess or checkers, or even Fortnite has AI built into it, designing a school bus route. All of those things use AI's representation and reasoning. So how do we address it in school? Well, this is a really actually an easy one. In younger grades, kids often program robots, right? They program Ozobots, or they program Bbots, or they program Finches, or whatever. They're programming robots, and they're often making maps. They're learning how to read and interpret maps. So it can be fun to have them draw their own map and then program their robot on it. And you can talk about what's the best route. You can talk about how computers do that, how Google Maps work, for example, which is an example of representation and reasoning. Okay. And then as you get a little older, you can get into decision trees, you can get into classification tree. So There's a great lesson from Grok Academy, and I'll put the link in for that. And it has kids, and this is unplugged again. They're creating a tree structure classification system, and then they're about animals, so can fit into science classes, and then they're trying to classify an animal that's not in the tree. And it also can get into Boolean, because each of these decision is a yes or no answer. So you can get into those decisions as well. Great fit into your CS classes. Next. Big idea 3, which is all about learning. We hear machine learning all the time. Machine learning, what's machine learning, right? Well, this is what this big idea is about. It's about how computers can learn from patterns and data. Matt talked a lot about all this data, right, that's available in the world. Well, computers can evaluate that data and find patterns in it, patterns that we don't even see, right? But patterns, if you've ever taught primary grades, patterns is a biggie being taught in primary grades. They have to recognize patterns in math. Kids often are finding evidence based on patterns and things in science in all grades, right? So think about your life right now. You see machine learning at work when you train your phone to open because it learns your face, or Netflix recommends something to you based on your viewing habits. Okay, all of those are examples of machine learning that we encounter every day. So fortunately for us, K-2 students collect data. They collect it in math classes, they collect it in science, and hopefully they're collecting it in our CS classes, because there are a couple of CS standards that talk about collecting data. And so you can build off of those into an unplugged activity in how machine learning works. And this activity, which I will post a link to, involves a teacher created data, and which is all these pictures of healthy and unhealthy foods, and teacher created categories for the data, healthy and unhealthy. And it starts out by having kids actually sort the data. Is it a healthy food? Is it an unhealthy food? Okay, so they do that activity. And then we talk about, well, could a computer, and then we give them a new food. And what we actually give them as the new food is a green gummy bear. And we say, is that healthy or unhealthy? Well, kids are going to tell you it's unhealthy, right? Then the teacher actually uses Teachable Machine and trains it on the exact same data that the kids classified. And we show the machine the picture of the green gummy bear. And guess what? It thinks it's healthy. It's because we bias the data set on purpose so that all of the healthy foods were green. You see here more of the data that got added on the healthy side. It doesn't start out that way. It's all green foods. And so it will tell you that it's unhealthy. And then we have kids think about, well, what else could we add to the training to make it start to recognize that it's unhealthy? So it gets into all of those things with learning and bias and all of that. And the kids aren't touching the computer. The teacher does Teachable Machine. And then on the 3 to 8 one is machine learning for kids. If you've never seen machine learning for kids, awesome site. You can program in Python or in Scratch on it. And there's so many different lessons there, and it has you create data sets and then has you write programs against those data sets to see how they're working. So it's an awesome site and it's free. And I highly recommend that if you want to get into teaching kids about machine learning. Next. big idea 4, natural interaction. Um, we we're seeing a lot of this these days with the rise of generative AI. Generative AI interacts with us extremely naturally, right? We carry on conversations with ChatGPT, right? We tell it, oh, you did that wrong. Try this, whatever. So we're seeing a lot of that interaction these days. But generative AI, like ChatGPT and other things, they're leading people to believe that AI is kind of this magic thing and it's creative. And maybe it's even more intelligent than humans are. And maybe it's on that precipice of becoming self-aware, right? It's not, okay? That's not the case. Um, but if we sometimes see that as adults, kids would definitely see that, right? They'd think, oh, magic, right? It's not magic. So we want our students to understand how it works. So they understand it's not magic, it's actually math, but we don't even have to say it's math, but that's what it is. So all of the examples here teach kids at different levels how large language models work. ChatGPT is a large language model. For our youngest students, even though I have used this with older students as well, you could use this with a variety of students. It was designed for K-2, and basically it simulates in buckets or boxes or something a large language model. We create the model using sentence strips from the book Green Eggs and Ham. As we're doing it for the first few, we are also building an online model on slides to show what we're adding to the model. But all the kids add a sentence from Green Eggs and Ham to the model. Then they create their own sentences that are similar in structure, but they aren't from Green Eggs and Ham, and we add those. And then we generate sentences out of that by pulling things out of the different buckets, and we create sentences, right? So we are putting in things with words and the relationship between words so that we can generate sentences, and it's based on probability. So are large language models. They're based on words, the relationship between words, sometimes parts of words, because they'll take plurals off and add them on when it needs and stuff, and the relationships between words. And they give you the most probable or somewhat the most probable thing that'll complete whatever it is you want. So we're showing them how that works, all unplugged. The second one it says it's for K-12. I've typically used it 3 and up, third and up, but it's a series of lessons from Day of AI, and it's freely available as well. And basically that starts out having kids write stories together. Then the teacher does something with ChatGPT to show them how ChatGPT works, but the teacher's the one touching ChatGPT, not the kids. And the series of lessons culminates with students coming up with recommendations on how they think ChatGPT should be used in schools or not used in schools. So it gets them thinking in terms of how it works, things it does well, that kind of thing. And the last one's actually new from the Hour of Code. It's from Pick Code, and it's one where you're building a what they call little language model and working with it in JavaScript. So it's kind of teaching again how those language models work, but you're doing some programming against it in this case. And last, but certainly not really last, is societal impact, big idea 5. It's at the center of that graphic I showed at the beginning because it should be at the center of any teaching we do about AI. Because AI can impact society in both positive and negative ways. And it's important that even at K-2, they start thinking about that. So the lessons I've highlighted here, the first two are actually ones that we just released for CS Ed Week at AI for CA. And they both deal with teaching the impacts that technology has had on things so far, like the impact that technology's had on how we draw pictures or share pictures or create pictures to tell stories. And it looks historically at how that is. And then it gets into looking at how AI might impact that. And they actually do get hands-on with AutoDraw, which is one of Google's tools that uses AI to let you add things to your drawing, but you can use this tool, the AI drawing tool, not showing it here, to add things. Like I would not draw a dolphin very well, but in the example, I can draw a dolphin because I kind of sort of do it. It'll tell me what it thinks I'm drawing and let me pick the dolphin picture I like, and I can add it to my picture. So they do create a picture with that with AI. And we talk about how it works. Where does it get the data? How does it know how you're drawing it? We actually play a Pictionary game before we go into it, because Pictionary is very much like how AutoDraw works. AutoDraw watches how you're drawing something, just like we watch how somebody's drawing something when we're playing Pictionary and decide what it is. So we go with that. And then we talk about, is it a good thing or bad thing? We also provide examples of generative AI and ask if it's a good thing or bad thing. We do not have them do it themselves. The third to fifth grade option is very similar, but it's dealing with film. So it's dealing with both pictures or video and story. So it's putting both of them kind of into the mix. Again, the teacher's probably generating stuff. The kids may generate again with the same tool, with AutoDraw, for pictures when they get hands-on. In this one, the chat GBT portion, the teacher, of course, would be doing, but with input from the students. So the students could tell them what they wanted the theme of the story to be, who they wanted the main characters to be, things like that. And then the teacher could feed that in for them. And then they could look at the story and decide, is it good or bad? And if it's fair, right? So we're getting into that fairness thing. We get into ownership much in K-2. Who would own that, right? Kind of thing. The final one is in middle school. I've used it with fifth grade and up. Is lessons from MIT Raise. They have a lot of great AI lessons, and one of them is the AI and ethics for middle school curriculum. And it looks at, it's basically looking a lot at YouTube and redesigning YouTube to make it less biased in recommendations and things along those lines, and how they would improve it. So they're learning technical concepts on like how to train a classifier, but they're also learning about the ethical implications behind all of those technical concepts. And there's one more slide, Kat. So there's a ton of resources. These are just some of the ones that are out there that I have used and or recommended or whatever in the past. I don't think it's going to let me paste them all in. Oh, there we go. So that's the list. I highly recommend books if you're teaching the littles. The Ready AI books are awesome. You can purchase them anywhere. The books from AI Club, you can purchase them, but they are also available for free online if you want to just show them online. So.
Well, thank you, Vicki. What I was thinking too, you were sharing all these great resources, and at first I'm thinking, wow, these are great for computer science courses. And then I thought, well, not all elementary schools have a standalone CS course, but as you pointed out, our elementary teachers are teaching about mathematics and patterns and statistics and probability, and they're reading to kids, and there are these books. And so I love that these resources can work in a multitude of settings, right? And that's great. So thank you for that. All those wonderful, and a lot of these resources that Vicki shared, for example, the hands-on AI projects for classroom by ISTE, there are 9 to 12 resources available as well. If you go to the AI for CA group, there's 9-12 resources there as well. So while Vicki talked mostly about K-8, there's also a lot of 9-12 resources out there also. And so in many of these links also. So totally appreciate that. And I appreciate it also because there were some questions in the chat, and I've heard them as well, in regards to just how do we do this when, we've got these AI tools that aren't made for education and aren't for Bancopa compliant. And yet there are ways that Vicki showed us and that Matt talked about, that we can still build that AI literacy, even though we're not getting kids to necessarily, use ChatGPT in our class, so to speak. I also thought there was an interesting question that I saw earlier about the, different types of, where did it go? Trying to find it. I don't know. About the retrieval automated generative AI. And so essentially, utilizing, is there a move to say, well, we're not going to use all of the internet, right? Like Matt was talking about, but we're going to use like a textbook or, some of these resources that we know as teachers are good, and we're going to create a chat bot based on that. So it's an online tutor and such. And based on what I've seen in like ChatGPT-4, the ability to create your own chat bot and things like that, like I think that's probably, I'm not in the tech industry, so I'm not like developing these things, but I would imagine that that's going to be coming soon. The technology is certainly there. And so I would imagine that, I really feel that this is going to revolutionize the way we can personalize learning and all of that, but really looking beneath the hood and understanding how that works is so key. So I really appreciate all of what you've all shared today, and how important this all is. So I did see, we had some questions in the chat that we answered. If there's any others that you have for our speakers, feel free to check those out as well. Our AI guidance does have a link to our California Educators Together statewide AI group. And so there are many of these resources that were mentioned are there. So feel free to check that out. And also, I just wanted to let you know what we are going to continue to do to support you here at CDE and as a follow-up to this webinar. So all of you will receive a follow-up email within the next couple of days with links to the CDE AI resources that were mentioned. Actually, it won't be a PDF of this presentation. It'll be a view-only link. And that will have links to the resources mentioned and a feedback form. And so, and there will also be a link to a recording once that has been released as well. This was on CDE's Facebook page live, so if you wanted to watch it later, you can do that as well. And I see in the chat a thank you to Vicky for lesson resources that even non-CS teachers can use. So thank you for that. Definitely appreciate that. So these were our November and December offerings. We started this series back in September. We do have plans to continue throughout this school year. And so you be sure that if you have not already, you're going to want to be on our listserv. So I will have all of that information that's shown on this screen in the follow-up email so that you will know what is coming. There will be a couple of webinars in January and more continuing as well. So great question in the chat. As we contemplate using AI, what is or should be in place regarding individual privacy and cybersecurity? That is an excellent question. And I will say that our second AI webinar that we did was based on safe use and user privacy. And so we had some great resources shared from some individuals from Data Ethics for All and Common Sense Media and from Kern County Superintendent of Schools that shared about how to ensure that we have some safeguards in place. There's some information on our AI guidance in regards to questions to ask and things to consider as well. But what I can do is ensure that because that question was asked, I'll put a link to the prior recordings for those that are interested in that as well, if you weren't able to go to some of those webinars. Also, I believe that those resources that were added to the chat, Vicky, are those all linked in the slides?
They are they're in speaker notes, and they're also linked, like the pictures will, if you click on them, link as well. So once you have a link to the slides, you'll have the links that I posted.
Excellent, excellent. Well, I want to thank our speakers because you are getting some great thank yous in the chat. So thank you for that. We appreciate all that you do, and we will certainly keep in touch and let you know when our next webinars will be here. Thanks, everyone.
Thank you.
You.